Hello, this is Mr. Stansbury. I'm going to take you through the 19C assignment. I'm assuming that you've watched the 19C video as to how limits work and what they're all about, so I'm not going to go into great detail about that, but I will take you through each one of these problems and explain these. Okay, so first one, the limit as x approaches -6 from the negative side of 6. Okay, negative side of -6. So, -6, let's see, we've got 1, 2, 3, 4, here's -5. So let's put a nice line in there so we know where -5 is. So -6 is this here. Okay, so this is saying as we're approaching -6 from the negative side. So here's -6, the negative side is over here. So basically I'm going to go to -6, go over, and then find the graph. Here it is down here. And now I'm going to just say, okay, what number, as I'm moving along this line, getting closer and closer to -6, what number is x, what's the x value getting closer and closer to? Okay, sorry, not the x value, but the y value. So as we're going along this line here, the y value is getting closer and closer to -1 right here. So this is simply going to be -1, okay, because I'm approaching -6 from the negative side. That is getting closer and closer to the value -1. There's 0, there's -1, -2, -3, -4, so forth and so on. Okay? So, the next one here, the limit of f of x as x approaches -6 from the positive side. So here's -6. Now, I'm going to go to the right and find the graph. Now the graph's up here. As I'm getting closer and closer to -6 from the positive side of -6, this y value is getting closer and closer to this point right here, which is 1, 2, 3, 4. So then this limit here is +4. Okay. Now it asks, what's the limit as x approaches -6? So what that means is we're approaching -6 from both the negative side and the positive side at the same time. Okay. Now, if these are both heading towards the same value, which they're not, if they're both heading towards the same value, it would be whatever value that is. But since they're heading towards two separate values, as we're approaching -6 from the negative side, it's getting closer and closer to -1 for the y value. And then the y value as we approach -6 from the positive side is getting to 4. So since they are not going to the same value, this limit does not exist. Okay, just like it says right up here, that the limit does not exist. Okay, moving on to number 4. As x approaches -3 from the positive side, so 1, 2, 3. So -3 from the positive side, so over here, as we're approaching -3, closer and closer and closer to -3, we are getting closer and closer to the y value of -3. Okay, so then the limit as x approaches -3 altogether, so that's -3 from both sides. It didn't ask us what's the limit as x approaches -3 from the negative side. So here's -3 from the negative side. It is also approaching -3. So since it's approaching -3 from the positive side and -3 from the negative side, the limit as x approaches -3 is -3 for the y value. Okay. Limit as x approaches -1 from the negative side. So here is -1. Okay, so as it's approaching -1 from the negative side, so here's -1, the negative side's over here. So as we're getting closer and closer to -1, this value is getting closer and closer to +2. Now up here when it is actually at 2, the value is 3. It's this little jump up here. But we're not worried about what happens at 2. We're worried about what's happening as it's happening as it's getting closer and closer to -1, not what happens at -1. Okay? The limit as x approaches -1 from the positive side, so here's -1, positive side is over here towards the positive. As we're going back closer and closer to -1 from on the positive side, we are also approaching the value of 2. So that means the limit as you approach -1 from both the negative and the positive at the same time, since they're both heading to the same value, the limit will then just be 2. Okay. Number 9, the limit as x approaches 1. So here is the value 1. So from both the negative side, it's approaching negative 1, and from the positive side, it's approaching negative 1. So this value here will simply be negative 1. Okay. 10, the limit as x approaches 3. 1, 2, 3. That's 3 right here. Here's the value of 5. As x is approaching 3 from the negative side. So from the negative side, so I go to the left of 3, that's the negative side, find the graph, and this thing is going forever and ever down. Okay, when you get these things that just run off the graph here, there should be arrows on there. I just didn't have, just didn't put them on there, sorry. So as we're approaching positive 3 from the negative side, this is going down really fast. So this is basically going towards negative infinity. Okay. For 11, as x approaches 3 from the positive side, so go to the positive side of 3, find the graph. This here is getting closer and closer to positive infinity. All right. So the limit as x approaches 3 in general, so as it's approaching from both the negative side and the positive side, since they're going to 2 different values, the limit does not exist. Okay? Okay, for 13 here, as x approaches 8, 5, 6, 7, 8, that's this right here. As x approaches 8 from the positive side, so here's 8, the positive side, find the graph. This is going towards negative infinity. Okay, and then it simply asks what's the value as, what's the limit as x approaches positive 8 altogether. So from the positive side, we just figured out it goes to negative infinity. From the negative side of 8, as it's getting closer and closer to 8, it's also approaching negative infinity. So since they're both going to the same value of negative infinity, then we say that the limit is negative infinity as x approaches 8. Okay? So that's the front half of this assignment here. Let's take a look at the other half. All right, backside here, number 15. Find limit if it exists. So the limit as x approaches 2. So you can see why we have to figure out the limit of this here, because if you put 2 into this here, we've got 2 minus 2, we're dividing by 0, and we know we can't do that. So we're trying to figure out what happens as the value gets closer and closer to 2. Okay. One thing you can always do with these, especially since our when we're taking our IB test, you can actually use your graphing calculator. You can always plug this in to the calculator and see what's happening as it approaches 2. But another way that we can do this is with some of these, we can factor them out. So like this one, for example, x squared minus 4 is a difference of perfect squares. So that's just going to be x plus 2 times x minus 2 is what this turns into. And then it's still over x minus 2. So you cancel those 2 out and you're just left with x plus 2. When you plug 2 into that, you just get 2 plus 2, which gives us 4. So the limit of this one here as x approaches 2 is simply 4. That's actually probably easier than plugging into the graphing calculator. But if you get stuck and you want to take a look, the graphing calculator will probably work as well. All right, this one here, x squared minus 9. That's also a difference of squares. X plus 3 times x minus 3 all over x plus 3. And look, magically one of those x plus 3's are gone. So if we plug in negative 3 to this, negative 3 minus 3 gives us negative 6. So the limit as x approaches negative 3 of this equation here the value will be getting closer and closer to negative 6. Now that's from both the positive side of negative 3 and the negative side of negative 3, if you remember from the front side of the worksheet. Okay, this one here, still perfect difference of perfect squares. X plus 5, x minus 5, all over x minus 5. So those x minus 5's reduce out, and we put in 5. 5 plus 5 gives us 10. So the limit of this one would be 10. Okay, let's move on to the next 3. So Let's see, I thought we just did those. We did those. Let's do, there we are. Okay, the limit as x approaches 5. So this one here, let's see if this factors out. Now, kind of a hint on this one here, x minus 5. Hopefully one of these factors is x minus 5 so that these can actually reduce out. So factors of 5 that have a difference of 4 are 5 and 1. Right, and then since this has to be -4, that's -5 and +1. So those are the factors. Those reduce out. We're left with x plus 1. So if we plug in 5, 5 plus 1 will give us 6. So the limit on 18 would be 6. This one here, let's see if this factors out. Let's see, hopefully it's got an x plus 2 as a factor. Factors of 8 that add up to 6 are 4 and 2. And they have to add up to 6, so x plus 4 and x plus 2, so that works. And then x plus 2 here, those reduce out, and we put -2 plus 4, gives us that this limit here is 2. Okay, now 20. This one does not simplify like all these other ones did, so graphing calculator would work out just fine for this. Another thing you could do for this is you could make your make a t-chart here. All right, so I'll just show you that and then show you the graphing calculator, and then you can decide which way you want to go with this one. So x and y. So we would want to pick some numbers that are really close to -2 on both the positive and the negative side. So on the negative side of -2 would be -2.1, -2.01, -2.001, right? And then on the positive side of -2 would be -1.9, -1.99, and -1.999. Okay, so we can plug in these values into that, and away we go. It's going to be significantly easier if we plug this in to the graphing calculator. Now, you can do -2.1 plus 6 equals, divide by -2.1 plus 2 in there into your graphing calculator and do all these by hand, which will take you a little bit of time. Or what you can do is we can actually plug this into the y equals, plug this equation in. Now, don't forget, these need parentheses when you're plugging those into the calculator, right? So it's got to be parentheses. We want all of x plus 6 to be divided by all of x plus 2. If you don't put the parentheses on there, it's going to take 6 and divide it by x, and then it's going to add that to x, and then it's going to add 2 to that. It's going to be completely different. Okay, so let's just take a look and see what this graph looks like. The zoom standard should usually give us a pretty good idea what's going on. Remember this for you folks with the 83. That's the glitch of the TI-83. It's kind of the asymptote, not entirely, but that's about where the asymptote would go. But you don't have to worry about that. So, nice part about having this graph here is now we can do second calculate, and we can plug in whatever x values we want. So we put in x equals -2.1, and we get that that's -39. Okay, and then we can, nice part about this is now you can plug in all your other numbers, so just, you don't even have to do second calculate again. You just do -2.01, and that gives us -399. Right, and then we do -2.001, and that gives us -3,999. So this basically here, this is going towards -infinity, right? So let's see what's happening on the positive side here. Okay, so we plug in -1.9, and we get 41. -1.99, that's getting a little closer to -2, and that's 401. And then -1.999 gets us to 4001. So this basically here is going towards positive infinity. Okay, so we figured out what's happening on the negative side of -2, and we also figured out what's going on the positive side of -2, and they're going towards different numbers here and different values. So on this here, the limit does not exist. Okay. Now, nice part about this is on this graphing calculator, you can actually see what's happening here. You can tell that the limit doesn't exist, because if we just do, it's the one time when you would actually want to use good old trace. So here we are where x is -2.97. As we get closer and closer to -2 from the negative side, watch what this y value does. It's -4.2. We move it again, -6, -10, -30. It's getting bigger and bigger, and then now it's actually jumped up to the other side. So as we start over here, the positive side, it's 4.4, 5.2, 6.5, 8.8. It's getting bigger and bigger every time that we move closer and closer to -2. So then you can tell that that's going to positive infinity. This other side was going to negative infinity, so the limit doesn't exist. Okay, so that's both the table way and the graphing calculator way. Okay, let's move on to the next set, 21 through 23. Let's see. This looks like this might factor. Let's see if that will help us. X plus 1, x minus 1. This down here hopefully has one of those two same factors. Factors of 2 that have a difference of 1 are 2 and 1, x and x. And we know that these have to add up to positive 1. So it's going to be positive 2 and -1. So look, those go away. And if we plug in 2 plus 2 in the denominator gives us 4. That's okay. As long as it doesn't end up getting our denominator to equal 0, then we're okay. So let's plug it in. 2 plus 1 over 2 plus 2 gives us that the limit on this one here is 3/4. So if you can tell, remember from number 21, if you can factor this, it's significantly faster than going on the graphing calculator and looking all up on that. So our first line of defense is to try to factor this stuff. So let's see if this will factor. Factors of 9 that add up to 6 are 3 and 3. And that has to add up to -6, so those have to be negative and negative. -3 and -3 is -6. And on the bottom, this is a difference of perfect squares. So that's x plus 3 times x minus 3 will give us x squared minus 9. So these reduce out, and if we plug a 3 into the denominator, that still doesn't give us 0. So we can do this. 3 minus 3 over 3 plus 3. So that gives us 0 over 6, which gives us that our limit is 0. Okay, 23. Let's keep trying this factoring trick here. Not trick, but technique. Perfect square minus perfect square, so it's x plus 5 and x minus 5. Factors of 15 that have a difference of 2. So 15 is 1 times 15, or 3 times 5. Those have a difference of 2. So we'll do x and x. 3 and 5, doesn't matter which one goes where. And then we know that these two numbers here have to add up to -2. So it'd have to be -5 plus 3. Okay, these -5s will then reduce out. Now, problem is, if we put -5 in here, -5 plus 5 does give us 0. So we know that we cannot do that. So let's take a look at this one here on the calculator. Okay, now you could, we know that this here simplifies to this. So you could, in your y equals, just put this over this in. Just in case if I messed up the factoring, I'm just going to put the whole thing in. Okay, I'm feeling pretty good about our factoring, but you know, it doesn't hurt. So x squared, all in parentheses, minus 2x minus 15, parentheses, divide by parentheses, all of the bottom, x squared minus 25. Okay, and then we go to graph that, and we should be able to get a good idea of what's going on here at -5, right? So look, Negative 1, 2, 3, 4. There's negative 5. From the negative side, it's going to positive infinity. From the positive side, it's going towards negative infinity. And again, if you really want to double check, you can always do trace, and then we'll just hold that and get that thing over. Let's check from the negative side first. So, negative 7. As we're getting closer and closer to negative 5, watch what happens to our y value. 2, 3, 4, 7. It's getting big fast. Okay? And then now, it's eventually going to end up going down over here to the other side. So as we get closer and closer to negative 5, watch what happens to the y value. Negative 1, negative 2, negative 5, negative 17, and then it jumps back to the other half. So this is going towards positive infinity. This goes towards negative infinity. So the limit on this one does not exist. Okay? Let's take a look at these here. If we plug in 2, it doesn't work. So let's try our graphing calculator again on this one here. So we have 4. There's just 4 up there. We don't have to use parentheses around 4. You can, it won't hurt, but and then around you do have to have the parentheses on the bottom. So we've got x minus 2. Okay, and then we graph that. And let's see what's happening at 2. Now it says not just 2, but 2 from the negative side. So there's 2 from the negative side. You can look at the graph and tell right there that thing's going towards negative infinity. So this thing here is negative infinity. Now look, it's the exact same equation here. Now it's saying what's happening as it's approaching 2 from the positive side. As it's approaching 2, getting closer and closer to from the positive side, so basically it's moving left towards that. That is getting closer and closer to positive infinity. Okay, so then they ask at the end here, what is the limit as x approaches 2? So we can tell from this graph, as it's approaching the negative side, it's going towards negative infinity. As it's approaching from the positive side, it goes towards positive infinity. So since they're not going to the same value, one's going down, one's going up, the limit does not exist. All right. 27 and 28. The function f is defined by x minus 2 when x is less than 1. And then it's x squared for when x is greater than 1. So this is like a function. It's basically it's a piecewise function. Okay, so you're getting 2 different values. Okay, using 2 different equations for what's when x is less than 1 and when x is greater than 1. And of course it's asking what's the limit as x approaches 1. So basically what this is going to look like is this is going to look like what we did back up here. Okay, so it's going to look something like this. Like this is a function and this is a different function. So it's going to have, if we were to graph our functions, it's going to look something strange like this. Okay, this is obviously not one equation. This is many different functions. And this function here is from what, like negative 6 to negative 10. Anyway, heading back to what we were at here. Oops, gotta turn that off. Okay, so it's x minus 2 when x is less than 1. So really on these here, probably our easiest bet to hopefully be the least confused is to put this into some t-charts here. So we got x and we got y. So when x is less than 1, and we're trying to figure out the limit as x approaches 1. So this is going to be from the negative side, and then this is when x is greater than 1. This is as x approaches as x approaches 1 from the positive side. Okay, so let's do the negative side here. So we're going to use this equation when x is less than 1. So let's do, if it's less than 1, that's going to be 0.9, 0.99, and 0.999. Okay, so if we plug in 0.9, 0.9 minus 2 is going to give us negative 1.1. 0.99 minus 2, that's a lot closer to 1. So 0.99 minus 2 is going to give us negative 1.01. You can do these on your calculator as well. And then 0.999 minus 2 is going to give us negative 1.001. So you can tell as we get closer and closer to x, hopefully you can look at this thing here and say we are approaching negative 1. So the limit as x approaches 1 from the negative side is negative 1. Now let's see what happens on the x squared. Okay, so this is when x is greater than 1. So it's approaching from the positive side of 1. So again, just to kind of help out here, here's 1. This is the negative side. Here's the positive side. So this is, say, 2, and this is, say, 0. So as we're approaching 1 from the negative side, remember we're going this way. So that's why we said like 0.9 is right here. 0.99 is right here. 0.999. We're getting really, really close to 1. So as we're approaching 1 from the positive side, that's going to be, say, 1.1. Oops. And then 1.01 and 1.001. That gets us closer and closer, moves us closer and closer to 1. Okay, so if we put 1.1 squared in here, and again, we could do this on here. Might as well. So we can do, we're just doing x squared. Don't really entirely care that much about the graph. You can kind of see what's happening here. But now we can do second calculate, and we can do whatever values we want. So I want to know what it is when it's 1.1. So 1.1 squared is 1.21. And then let's put in 1.01. You square that, you get 1.021. 1.0201, I think is what it said, right? Yep. And then 1.001 will give us that's weird, 1.002001. So basically, if you just look at these numbers here, 1.2 to 1.02, 1.002, this is getting closer and closer to positive 1. So the limit as x approaches 1 from the negative side is negative 1. From the positive side, it's positive 1. So since they're not going to the exact same number, the limit does not exist. Okay. 28, we'll want to do basically the same thing. Make ourselves a little t-chart here. And we'll do, it's x plus 3 for when x is less than 2, and then negative x plus 7 when x is greater than 2. So we'll do this from the negative side of 2, and this from the positive side of 2, because this here is x is less than 2, that's the negative side. X is greater than 2, that's the positive side. Okay, so here is 2. The negative side is, oops, getting closer and closer to 1. The positive side is 3, right? So this is positive, and this is negative side of 2. So this side of 2, we'd go with, say, 1.9, 1.99, and 1.999. Okay, and then on the positive side of 2, we'd say go 2.1, 2.01, 2.001, and that's helps us get closer and closer to 2 from both the negative and the positive side. Okay, so if we pull up our graphing calculator here, we can put in, well, you know, yeah, I guess we could put it in here, but I don't think we're going to need to. 1.9 plus 3 is 4.9. 1.99 plus 3 is 4.99, and this is going to be 4.999. So hopefully we can see that this here is going towards, the limit is approaching 5 for this one here. As we do this, negative 2.1 plus 7 is 4, isn't that 4.9? Right, because we got negative 2.1 plus 7. And then 2.01, negative 2.01 plus 7 is 4. Let's see, 4.99, right? Yep, there we go. And then negative 2.001 plus 7 gives us 4.999. This here is also approaching 5. So since the limit is approaching 5 from both sides of 2, the negative side and the positive side, then we can say that this limit here is going to be 5. Okay, last two problems here. Find the limit if it exists. What is the limit as x approaches infinity? As we have 1 over x minus 1. So I'm going to make a t-chart because I think this is going to help us understand this a little bit better than just looking at it on the graphing calculator. But we can look at it on the graphing calculator at the end too. So just, as we're approaching infinity, so let's just pick a big number, say 100, and then we're going to pick a bigger number, 1,000, and then we're going to pick a bigger number, 10,000, and let's see what happens. 1 over 100 minus 1. Let's see. Let's see. 1 divided by 100 minus 1 gives us 0.01. 0.0101. Okay, and then if we do 1 divided by 1,000 minus 1, we get 0.001001. Okay, and then if we do 1 divided by 10,000 minus 1, that gives us e to the negative 4. So we're going to move the decimal back over 1, 2, 3, 4 spots. So that's 0.0001. So as you can see here, this is getting closer and closer to 0 with the bigger number that we put in. Okay. Sorry, there is no positive or negative side of infinity. I don't know why I made that. My apologies. We do not need this part down here. Okay, so as this number gets bigger and bigger, this number here, our value here is going to get closer and closer to 0. So there's our limit. The limit is 0. Okay, so this one over here, the limit as x approaches infinity of x over x squared minus 1. Okay, so now this might be, we could have done this on the last one too, but this might be a good one to put into the graphing calculator. So we've got x divided by, and then we've got x squared minus 1. Oh, sorry, plus 1. Okay, so we can graph that and kind of show us a strange looking graph, but really we don't even need that. But this tells us that it looks like it's going to be at 0. So let's double check. Second, calculate, and now we can put in all the values that we want. So we're going to go as we're approaching infinity. So let's do the same thing. Let's say 100, 1,000, and 10,000, and let's see what we get. Okay, so we'll do value, and if we plug in 100, it'll tell us what the value is. Oh man, let's see, go to, what kind of error did I make here? Clear, y equals x over x squared plus 1. I don't know why it doesn't want to help me out here. The calculator will not, it does not like doing the big numbers on this one apparently. So let's just do this in our head. So basically this is going to be 100 over 100 squared. That's going to be a big number, right? So that's going to be what? Let's see, 10,000 plus 1. So that's going to give us a pretty small number, right? And then as we're doing, if we put in 1,000, that's going to be 1,000 divided by, now that's going to be what, 1,000,000 down here? Plus 1. That's going to be a smaller number. And then if we put in 10,000, that's going to be 10,000 over, it's going to be 8 zeros. And this is going to be even smaller still. Right? I know that that's not very satisfying just saying smaller number and smaller number still. So let's just figure out what they are. So we've got 100 divided by, that's going to be what, 10,001? Right? So that gives us 0.01. Okay, and then we do this next one here. That's going to be 1,000 divided by, and then we've got one, what was this, a million? Yeah, 1,000,001. Right? Yep, that's 1,000,001. And that gives us 9.99. So let's move the decimal back over 1, 2, 3, 4 spots. That's 0,009. So that's basically 0,001. Okay, and if we do this one here, it's going to be 0.0001. So this one here also goes to 0, the limit. Okay, I know these get a little weird and a little tricky, but you can see these on your graphing calculator. In fact, we could even zoom in to see what's going on. Oops, if we do zoom box, that might help us really figure out what we want to see. There's our cursor. Okay, so we're going to move that over here. We really want to see what's happening really as x is getting closer and closer to oh wait, oh no, sorry, as it's getting towards infinity, this zoom box isn't going to help us at all. Okay, but you can tell here on the graph as we're getting bigger and bigger. Let's do this, maybe window, x minimum, 0, x maximum. Let's do 1,000, and then the y minimum. Let's do, say, -1, because it looked like it was getting really close to the graph here. So here's our graph. It comes down here, and it's just right along this line here. It is really close to 0, which is what it's showing. Okay? All right. If you have any further questions on this, please feel free to ask in class. Thanks.